Children, next we are going to learn about chemical equilibrium. Chemical reaction gradually attain a state of equilibrium after some time. For example, A plus B giving C plus D. This is the reversible reaction. A plus B giving C plus D is forward reaction. C plus D giving A plus B is the reverse reaction. Initially, that is starting of the reaction, only A and B are present. Then after some time, C and D, the products are formed. So, as the concentration of the product increases, more products collide with each other and react and gives the backward reaction. So if the backward reaction increases, if the reverse reaction increases, the rate of the forward reaction gets decreased. Then eventually, after some time, the rate of forward as well as the rate of backward becomes equal, and this is called equilibrium. For example, if you are considering a graph, this is reaction rate, time. First, forward reaction moves like this, then backward reaction also moves like this. At a particular stage, both get collide. That is equal rate. Equal rate. That state is called as equilibrium. If you are taking concentration versus time, see, this is the reactant and this is the product. They will not collide. No change occurs. So, a chemical equilibrium is said to be dynamic when. Dynamic means when. At equilibrium, forward, this is the forward reaction, this is the backward reaction. At equilibrium, the forward and backward proceeding in the same rate, and no macroscopic change occurs in the reaction. So, chemical equilibrium is said to be dynamic in this process, where there is no macroscopic change. Forward, backward proceeding at the same rate. No macroscopic change occurs. At this situation, equilibrium is said to be dynamic. For example, H2 gas plus I2 gas giving 2HI gas. 1 mole of H2, 1 mole of I2, 1 plus 1, 2 moles, giving 2 moles of HI. No macroscopic change. Now, chemical equilibrium divides into two types: homogeneous equilibrium, heterogeneous equilibrium. Homo means same, hetero means different. Homo, all reactants and products are in same phase. Same example, H2 gas plus I2 gas giving 2HI gas. All are in gaseous condition. That is called homo. One more example, ester, CH3COO CH3, methyl acetate with water. Methyl acetate is aqueous. Water is also aqueous, giving acetic acid, aqueous, plus alcohol, that is methanol, aqueous. Another example, all the reactants and product are in same phase. Now heterogeneous, the reactants and products are in different phase. For example, H2O gas becomes H2O solid, different phase. So in 1864, two scientists, Macmillan and Peter, formulated laws of mass action. What is law of mass action? It states that at any instant, the rate of a chemical reaction at a given temperature directly proportional to the product of active masses of the reactants at that instant. That is, rate directly proportional to active mass or concentration, both are same. Rate of a reaction directly proportional to active mass of the reactant at that instant. So law of mass action given as rate proportional to active mass of the reactant power x. What is x? X denotes stoichiometric coefficient of the reactant. This bracket indicates active mass or concentration of reactant. That is, active mass is equal to N by V mole decimeter cube or mole per liter. N means number of moles, V volume of the container in decimeter cube or liter. Now consider a reversible reaction. A plus B giving C plus D, X, Y, L, M, these are the coefficients, stoichiometric coefficients. So now A, B are reactants, C and D are products. Children understood? A and B are reactants, C and D are products, X and Y, X, Y, L, M are stoichiometric coefficients. So now we apply the law of mass action for the forward reaction. Therefore, rate of the forward reaction directly proportional to active mass of the reactant. Here two reactants are there. So, active mass of A, coefficient X goes to the power into active mass of B, the coefficient goes to the power Y. Taking the proportionality sign, Rf is equal to Kf. Kf means proportionality constant for the forward reaction. A power X, B power Y. Now, rate of the backward reaction. Backward reaction directly proportional to concentration of C power L, concentration of D power M. Taking the proportionality sign, rate of backward reaction is equal to Kb, concentration of C power L, concentration of D power M. At equilibrium, rate of forward reaction equal to rate of backward reaction. So, rate of forward reaction means Kf A power X, B power Y equals to backward reaction C power L, D power M, Kb. So here Kf by Kb equals to, this goes up C power L, D power M by A power X, B power Y. Kf by Kb for rate of forward, rate of backward, that is equal to Kc. Kc means equilibrium constant. So, what is equilibrium constant? So, equilibrium constant Kc is equal to C power L d power m by a power x and b power y. Already you know C and D are products. A and B are reactants. C into D, product of products to product of reactants. Product means multiplication. These two are products, these two are reactants. That is product of products and product of reactants. So it is defined as at a given temperature, the product of concentration of products raised to stoichiometric coefficient divided by product of concentration of reactants raised to stoichiometric coefficient which has a constant value, that is called equilibrium constant, and this is called as equilibrium law. It is given clearly in your book, children. You can follow. Suppose if the reactants and product are in gaseous condition, all are gases, reactants as well as the products. In that case, instead of Kc, you have to write Kp. Kp means partial pressure. Then you have to apply pressure here. P into C power L into P into D power M by P into A power X into P into B power Y. P means partial pressure. So this is the case for partial pressures. This is the case for concentration, equilibrium constant. C power L, D power. Concentration term should be used. For partial pressures, P term should be used. Children, everything given clearly in your book, can go through.